Algebra 1, Lesson 93, we are dividing polynomials. So in the last lesson, we were dividing fractions, and dividing polynomials really is very similar. So if I want to take 8x cubed plus 12x squared plus 4x and divide it by 4x, that's really just like what we did, 8x cubed plus 12x squared plus 4x. We're going to divide it by 4x. Now there's two major ways to do this. One is to take this 4x, since it's a monomial, and divide each term by it. So I'm going to do 8x cubed divided by 4x plus 12x squared divided by 4x and 4x divided by 4x. When we do this, we see that the first term is going to give us 2x squared, second term is going to give us 3x, and the last term is going to give us plus 1. So you can take, if you're taking a polynomial divided by a monomial, you can take each term and divide by the monomial. Or you could factor and say the numerator can be factored by taking out a 4x, so that I have a 2x cubed plus 3x plus 1 over 4x. And we see these two factors of 4x can cancel out, so I'm left with 2x cubed plus 3x plus 1. Either way works when you're taking a polynomial divided by a monomial. So I'll show you each way once more. So I'm going to take each of these terms and divide it by 2x in this case. Okay, in my first term I get 3x to the third, second term I get 2x squared, and last term I get minus 1x. Okay, and now let me show you with the factoring method again. I'll do this one again with the factoring method. I'm going to factor out a 2x from each term and get a 3x cubed plus 2x squared minus x over 2x, and so the 2x's can simplify and I'm left with my answer. Now that's with monomials. Binomials are a little bit different, okay, and there's going to be three major ways that we can do this. Okay, when we know that we can factor a trinomial, or even something that has 4 terms, we're going to go ahead and do that. So in this case, I can factor this guy and say, all right, what multiplies to positive 9 adds to negative 6? Well, we have an x minus 3 times x minus 3. And I'm going to divide that by x minus 3, meaning that I can simplify my factors here to get my answer of x minus 3. So when you know your trinomial is actually able to be factored, go ahead and factor it. So like this one, I'm going to factor it to say I have x squared minus 5x plus 6. So something that multiplies to positive 6 adds to negative 5. And that would be x minus 3 times x minus 2. And that's divided by 2 minus x. Now you'll see that x minus 2 and 2 minus x are not the same. But I could factor that denominator to say, well, that's the same thing as negative 1 times a positive x and a negative 2. Which means I now have similar factors in the numerator and denominator that I can simplify. So I have x minus 3 divided by negative 1, which is a negative x plus 3. So sometimes we can manipulate things that can find us our factors. Okay, and once again with the second one, I'm going to factor it. So we get x plus 7 and x minus 2 divided by 2 minus x. So I'm going to factor the denominator just like the other one by taking out a negative 1 to get x minus 2 over x plus 7 times x minus 2, which means these factors of x minus 2 can cancel out, and I'm left with x plus 7 divided by negative 1, so we get negative x minus 7 as my answer. So first way, when we're taking a trinomial or a polynomial divided by a binomial, it's to see if we can factor it. The second way is using something that you learned long ago, and that is long division. This one honestly is a bit hard to see when you first learn it. It is helpful in some situations, so let's try it, see if it works for you. So we want to take x squared plus 3x plus 2 and divide it by x plus 1. Now, yes, this one is one that we can actually divide evenly, but we'll see that in just a second. Okay, you could actually factor this one and divide, but I want to show you this long division. So if I do this, normally when I divide, let's say we're taking 324 and dividing it by 4. So I would say, okay, does 4 go into 3? And we would say no. Okay, we have a 0 there. Does 4 go into 32? We would say yes. Goes in there 8 times. So we do 8 times 4 gives me 32, and I subtract the 2. And I have a remainder of 0, so I pull down this 4. 4 goes into 4 once. 4 times 1 is 4, so I subtract it. I have a remainder of 0. So 324 divided by 4 is 81. We're going to do something similar here, same steps, but with variables. So I'm going to say x plus 1 goes in, does it go into x squared? And we say no. We would have too much extra. But does it go into x squared plus 3x? Yes. We can say that it goes into x squared plus 3x a minimum of x times. And the reason I chose x is because when I do x times x here, I get x squared. X times 1 is plus 1x. And just like I do my normal long division, I'm going to subtract this amount from what I have. So x squared minus x squared is 0x squared. 3x minus 1x is 2x. And I bring down my 2. Now I say x plus 1 into 2x plus 2. That can happen twice. So I say 2 times x is 2x. 2 times 1 is 2. I subtract this amount, and I end up with 0. So we would say that x squared plus 3x plus 2 divided by x plus 1 is x plus 2. So this is with long division. Okay. Let's try it again with this one here. So we are going to, I'm going to first show you the long division, and then I'm going to use this box in just a second in order to show you another method of dividing these. Okay, just going to get this a little bit out of the way. So x minus 8 goes into 3x squared 0 times, but it does go into 3x squared minus 25x. If that happens 3x times. I'm really looking to get rid of this 3x squared. That's what I'm trying to do. And that's why I pick 3x times x gives me 3x squared. 3x times negative 8 is minus 24x. And remember, I'm going to subtract this amount. So that I have 3x squared minus 3x squared is 0x. Negative 25x minus a negative 24x, that means I'm adding 24x, gives me a negative x plus 8. Then I say, okay, x minus 8 goes into negative x plus 8 negative 1 times. So negative 1 times x is a negative x. Negative 8 times negative 1 is plus 8. And remember, we're trying to subtract this. So negative x minus negative x is 0. 8 minus 8 is 0. And that's our goal. We want to get rid of things. So I would say that we divide it and we end up with 3x minus 1. Now, long division will work, and it is helpful for some people to understand it that way. I actually have another way that I like to do division of polynomials, and that is with a box. Now, this box, we've used it before in order to multiply different polynomials. Here we go. Maybe. Just try to move it up. I'm going to erase this a different way, go backwards a little bit. Okay, now I am going to use this box basically backwards from what we normally do with the area model. I am going to say, I know that one of my lengths here is x minus 8. I need to figure out what the other length is. That gives me 3x squared minus 25x plus 8. So I am basically working backwards to say, if that area is 3x squared, that must mean I am multiplying x by 3x. And now I can fill in another box here. I can say 3x times negative 8 is negative 24x. Now I want to get a full negative 25x, so I need to add to that a negative x, because that's what will give me my polynomial. So I'm saying, okay, now I have an area of 3x squared minus 24x minus x, which means that I must have a minus 1 here in order to get that negative x. And I say negative 1 times negative 8 is a positive 8, which gives me my correct area here, my correct polynomial, with now my two lengths of 3x minus 1 and x minus 8, meaning this is what I get when I divide the two. So area model is working backwards. So I'll show you with the long division method, and then I'll show you with the area method for this one. So once again, x minus 3 goes into 4x squared 0 times, but it can go into 4x squared plus 7x 4x times. So that we get, I'm going to subtract 4x squared minus 12x. So the 4x squareds go away, but I have 7x minus a negative 12x. That gives me a 19x. And then I bring down this plus 17. Now x minus 3 goes into 19x plus 17. I'm going to say 19 times. Okay, 19 times, because I want to get rid of that 19x plus 19. So I say 19 times x is 19x, and remember I'm subtracting this amount. And then 19 times a negative 3 is a negative 57. Okay, now the 19x's go away, that's good. But the 17 minus a negative 57 is going to give me a positive 74. That doesn't end up working out very well. But remember that when we have long division, I can have a remainder. And this is where I say that my remainder is 74 divided by x minus 3. So we have this 4x plus 14, and we have a remainder of 74 over x minus 3. Now similarly, we're going to use this box method in order to see what happens here. And I just give myself enough space here. I don't really need all of those boxes. But I say, okay, one length is going to be x minus 3, and I need to find the other length. But it starts out with 4x squared. So I must have multiplied by 4x in order to get there. And then I fill in my next box by saying that's negative 12x. So in order to get to my 7x, I must have had a 19x. Because 19x plus negative 12x is a positive 7x. So I must have done x times 19 in order to get there. So 19 times negative 3 is negative 57. And once again, in order to get to this positive 17, I must have had 74 here. Now there's no way to take x times something giving me 74, okay? So that's where we get our remainder of 74 over x minus 3. Okay? If you think of it, 3 minus x times this fraction here would give me 74. So I say I get 4x plus 19 plus 74 over x minus 3. The more that you do this, the more it becomes clear. So I'm just going to do a few more examples here. Okay? Now sometimes there is a variable that is missing in here. So in this case, we didn't have an x squared, but we do have to represent it in our long division. So that we can say, all right, if x minus 3 is going into 3x cubed plus 0x squared, I can say that happens 3x times, or 3x squared times. So I get 3x squared times x is 3x cubed. And then 3x squared times negative 3 is minus 9x squared. Okay, so I end up with having a positive, because I'm subtracting a negative, so a positive 9x squared, and then I'll bring down this negative 2x. Now, x minus 3 into 9x squared minus 2x, I'm going to say that happens 9x times. So I get minus 9x squared, and then minus 27x. And I subtract that amount, and I get rid of my 9x squareds. Negative 2x minus a negative 27 gives me a 25x. Bring down the 5, and we see that 25x plus 25 Well, we're going to put in there 25 times of this, so plus 25. So 25 times x gives me that minus 25x that I need. And then 25 times -3 is minus 75. Once again, we're going to have a remainder here. That's okay. I'll write it over here. That this remainder is going to be 5 minus a negative 75, so 80. And once again, I can't take that 80 and do much more with it, so I write my remainder as plus 80 over x minus 3. So your remainder, that whole number, divided by your binomial outside. All right, this one I'm actually going to do as a box method, okay, just so that you can see it in a different way. So I have my side length of x and 2, and I need to get it to 13x squared. Remember, we're working backwards, so we know the area is 13x squared. It must have come from an x and a 13x. So I do 13x times 2 is 26x. So in order to get to a 5x, I must have subtracted a 21x. So x times something gave me negative 21x, so that must have been a negative 21. Negative 21 times 2 is a negative 42, and that actually gave me what I needed here. Okay, this area here gives me my polynomial, so we would say when we divide, 13x minus 21 is my answer. Works out nicely for that one. Okay. All right, here is another example that you can try for yourself here. Sometimes these will have to have a remainder, sometimes they're not, but just remember, if you have a polynomial that's out of order, put it in standard form and also show any variables that are not shown already. Just show it by a 0x. And last one that we're going to do, just like that area model, we can extend this to real life by saying Jim wants to find the length of the rectangular garden outside his office. The area is x squared minus 11x plus 30 feet squared. The width is x minus 6 feet. So we have this garden. We say the width is x minus 6 feet. I know that the area is x squared minus 11x plus 30, so I start saying if it is x squared, that must have been x right here. So that gives me a negative 6 by multiplying it out. And to get to negative 11x, I would have to have another negative 5x, because negative 6x plus negative 5x gives me negative 11x. Okay, well, in order to get that negative 5x, I must have had a negative 5. So negative 5 times negative 6 is positive 30, which works for my garden, which means that the width is x minus 6, the length is x minus 5 feet. So dividing polynomials, lots of different ways to do it. Think first about factoring those polynomials. Next, you can either use long division if that works for you, or you can use the box method and work backwards from that area that you have in order to find the length and the width of that amount. Well, I hope this is helpful for your homework and for studying.